All right, we're into part 4 of the layer 2 configuration. And I can't tell you how awesome this is for me because it's kind of my let's say how do I explain it? It's well, let me put it this way. This is my 14th year of training. I've been a lifelong trainer. It feels like, and just over the years, I've just seen training styles come and go. PowerPoints and then killer glossy animations. I was just having a conversation the other day with the group at CBT Nuggets, and I think the best way, and it's funny because it's kind of like I go back to the beginning of time, if you will. The best way somebody learns something is through apprenticeship. I mean, cavemen teaching each other how to start a fire by showing each other how to spark rocks and things like that. And that's really what my goal is in the CCNA lab series is to kind of go through an apprenticeship sort of thing to where I'm configuring a pretty wicked network in a branch office scenario, and you're just kind of like, oh, okay, how do you do that? And then you have the tools where you can go and you can do it yourself and try and start that caveman fire, if you will. So it's just cool for me to be able to do this type of series. And we left off. Let's see. In the last nugget, we went through, set up all of the trunks for the VLANs, made sure those were working, made sure the operating system was working correctly in GNS3. We went through the VLAN port assignments, and I kind of modified, as I mentioned at the end of the last nugget, to add in management for the wireless access points. Made a couple tweaks there, and now we're on to what I would think is maybe the most exciting piece of it all, and that is configuring the layer 3 switch. Now, as I mentioned earlier, configuring a layer 3 switch currently is not part of the CCNA objectives. This is above and beyond, but I would say in the real world, this is just how it's done. I mean, the layer 3 switching functionality, I just picked up, where was I? A Cisco small business switch. I'm trying to think what client it was for, but anyway, I picked up a layer 3 switch for, I want to say, $350. I mean, come on. $350 for a layer 3 switch? That's that's cheap. I mean, thousands and thousands of dollars is what it used to be. So it's becoming one of those features that's gone mainstream, and it's like power over Ethernet. I mean, it used to be like who had power over Ethernet. So anyway, let me bring this back around. Everybody's doing layer 3 switching. The router on a stick, yes, it's still valid. Yes, it's still on the CCN exam. Yes, I'm adding a supplement to this where I'm going to convert this whole configuration to sorry, not a layer 3 switch, but router on a stick config using RT1 as the router on a stick, just so you can see what it would look like and what the differences would be in that kind of configuration. But for now, let's look at this. We want to create routed interfaces on NLB1 switch 1. That's our core right here, this guy. So he is going to have routed interface for each of the VLANs. The interface should be assigned the first IP address from each of the VLAN subnets listed in the following table. Ensure they are functional, as in not shut down. And then it says the 10.1.254.0 should be configured as a routed interface on F1/15. Now, I believe we did that in the last nugget when we saw this routed port right here. So that's done, but we'll review it and I'll make sure it's pingable from there. But let's do it. So let's go into. Hang on, let me bring up GNS3. All right, and pull up switch 1. Console. There we go. All right, let me get this right to this screen. So I want to talk a little bit as we do this about layer 3 switching and so on. So we've got switch 1. Let me just first off do this command. I'm going to do show VLAN switch. Now again, the normal command on a regular switch is just show VLAN. We're on an Ether switch module. So this is what we did in the last nugget. We created the VLANs, and they were created, and we assigned the ports to the VLANs. Now you can see that I'm on switch 1, so the vast majority of the ports are in VLAN 68. Which is the server VLAN. I also have one port in the private lab VLAN, but don't let that deceive you, because we actually have quote-unquote ports in all these VLANs. The way that I would see that is to do a show interface trunk. And I can see that I actually have 2 trunks, well, 4 physical interfaces. I've got my 2 Ether channels, port channel 1 and port channel 2. And you can see when I look at this list, I've got VLANs allowed on trunk, 64, 66, 69, 71. You know, I go down this list. Now, you might be looking here and being like, okay, some is missing. Well, that's right. We actually pruned out manually by using the switch port allowed VLAN. Let me do show run interface port channel 1. You can see switch port trunk allowed VLAN, and we trimmed it down to exactly what switch 2 and switch 3 need, which is primarily the client stuff, the voice VLAN, the management VLAN for those traffic, and then the public Wi-Fi, I believe, are about the only VLANs that are allowed on there. So that's trimmed down. So I do see VLAN 68 is active because I've got ports assigned to it, but then all of these are considered active as well because they do have a port assigned to it, and that's going to be the trunk. Now, all of that is the layer 2 VLAN interfaces. That's all layer 2 functionality. And what I mean by that is, yes, people in VLAN 64 are going to be separate from VLAN 66, are going to be separate from VLAN 69. I've got that dividing line between them. But by adding the layer 3 functionality, which is going to be what we're doing right here, by going in and assigning each one of the routed interfaces, now we've got routers or routed ports that's able to get us out of the VLANs. So let me go through this, and actually I need to get my little notepad file open as well. Keep adding to that list. Enter a couple times there. And let me do the layer 3 config. Now I'm going to do a show IP interface brief. And right here we already have a preview of layer 3 config, meaning VLAN 71. Now that is the management interface, but it's a layer 3 address that I've assigned to this switch. So if I want to configure this switch as a router for the other VLANs, all I need to do is go in, let's go into global config mode, and do interface VLAN. Now again, the key, I'm going to tab it out so it sticks in our head, interface VLAN, and then I type in what VLAN number I want. Now we're going to start off with the voice VLAN, VLAN 64. Poof. I've created a routed interface for VLAN 64. Look at that. It just, poof, out of nowhere, this line protocol has changed state to UT. If I do a show IP interface brief, scroll down, and I can see that VLAN 64 is now in my list. It's like this magical routed interface came out, but now it's not. It's dead. It's not doing anything until I go in there and say IP address is going to be 10.1.64.1. Why? Because it said to assign the first IP address from that subnet. And I look at the VLAN 64 subnet, 10.1.64.1, and I can't forget this custom subnet mask, 255.255.254.0. Enter. I now have, I'm waiting for a firework to go off. Poof, there it was. I now have a routed interface for VLAN 64. So here's the idea. I now have all of my IP phones, right? That not pictured here. They're going to get IP addresses via DHCP for 10.1. Let's say it's 64.50. This guy's IP address is 64.50. He's going to have a default gateway of 10.1.64.1. So whenever he wants to get off his subnet, now why might he want to get off his subnet? I don't know. Maybe he wants to go to, okay, we haven't combined, here we go. We haven't combined this with the Nugget Labs corporate. So he needs to make a phone call to someone over in Nugget Labs corporate. Well, he's going to pick up his phone, dial let's say 1011, which happens to be this phone's extension right here. That's going to go to the call manager server that's sitting on here. We'll say it's this server right here. It's going to go, oh, well, that's an IP address in a different subnet. Let me contact them. It's going to send a message over here. Hey, phone, ring. And this phone goes, ring. And so it's now ringing. And the phone over here lifts the handset. And as soon as it does that, this phone will be delivered, as in the call manager will give it the IP address of this phone. And now all their communication will start going direct. They're going to start communicating directly between each other's IP address using a protocol called RTP, Real-Time Transfer Protocol. Now, okay, stop myself, Jeremy, stop. I'm not going into voice over IP, but the point of this is that they are now going direct between each other. They're not sending audio through the call manager server. They're going direct, and at that point, this guy has to get off his subnet. So all of his packets that are communicating between these phones are actually going up to the layer 3 switch, reaching 10.1.64.1. That's his default gateway. And the layer 3 switch is looking at its routing table and going, oh, okay, to get over to this phone, I've got to send it through the router, through the mystery cloud here that we haven't configured yet, through the whatever connection we have, and now I'm speaking to the other phone. So that's really what's happening when I'm configuring this. Now let me do a show IP route. Look at this. I now have a new connected interface. It's like, oh, yep, I'm now routing for the 10.1.64 subnet. Now, one thing you got to make sure of when you're, now this is a swouter. It's actually a switch inside of a router. But normally on layer 3 switches, you have to type in the command IP routing in global config mode to turn it on. So let's just for fun, I'm going to go in here and let's add in objective 6. Which is going to be layer 3 switching. So the first thing on switch 1 that I'm going to add in is IP routing, just so we don't forget that. And then we'll go through and start pasting in the IP address, the VLAN interface that we need to create. And so what we're going to do is create that for every single one of the VLANs. I'm not going to sit here and do it all while you're watching, but I'm going to now kind of use this as my template and replicate it for all the VLANs. Okay, poof. There it is, in a blink of an eye. All of the VLAN interfaces config has appeared. Well, actually, I didn't need to do this. Because we already had VLAN 71 previously configured. So let me eliminate that one. So I'm going to go in and now just copy and paste all of those into switch 1. Is that right? Biggest thing in copying and pasting, make sure you got the subnet mask right. Make sure you change all these digits. I think that looks good. So let me now do a show IP interface brief and just show once again we now have routed Okay. Oh, that's okay. We now have routed, I'll tell you why in a second. We now have routed interfaces for each one of these VLANs. And you know what? I'll tell you, in the real world, what I usually also add in here is descriptions. So I'll do description, client. Let's do client. Wait a sec. No, voice VLAN. Just as a side note, while I'm doing this. Let me mention why I do the voice VLAN first. There's actually a method to my madness. VLAN 64 is actually the first VLAN that's in this list at this site. So is there a specific reason? Yes, there is. When spanning tree fails over, like let's say, well, okay, there's no redundant links in this picture. Let me eliminate my chicken scratch there. There's no redundant links in this picture, but if there were, like let's say we had another switch right here, we had this kind of thing going on, backup links and all that. When spanning tree fails over, like let's say this switch dies, it was the root of spanning tree, which we're going to configure in a second. All the switches will then switch over and start using this guy as the root of spanning tree. Spanning tree fails over from the first VLAN down, and there's a delay between each one of the VLANs failing over. Now it's minute, it's like 100 milliseconds or something like that. It's a small amount, but if you've got 100 VLANs, that, and I hope you don't, but if you did have 100 VLANs, and your voice VLAN was the last one, which most people do because most of the time voice over IP is one of the newest things they add to the network, and if it's the last VLAN, then you've got to fail through all these other VLANs before you get to the voice VLAN. The impact of that is you have dropped phone calls, whereas normally you might have just had a little, oh, could you say that again? There was something weird on the line. That would be what it was if it was the first VLAN failing over. If it were the last VLAN failing over, you just get a hello. It's one of those kind of things. So let me finish adding the descriptions here. Okay, there we go. So I got those copied to my clipboard. I'm going to go back in here. It's just handy to be able to do. And I can paste those right over. Sometimes that's dangerous to do that, to just paste, blast config right back over. But in this case, it's totally safe. I just paste all the IP addresses right back over the config. And now, one of my favorite commands when I get to a switch that I've configured is to do a show interface description. And then I can just get a quick view of all the interfaces, and oh, it's so nice to be able to see exactly what's plugged in where, what each one of those VLANs are, because you don't always remember. Now, let me talk about why is VLAN, or I should say the interface for VLAN 70 down. Well, you remember VLAN 70 is our private lab. That's this guy right here, private lab VLAN. Now that one only exists right here in, let me delete all this stuff. It only exists in the MDF on switch 1. So we've got switch 1. This was going to be our little private lab that the company graciously allowed us to come in and work there. However, there has been no ports assigned to that switch in VLAN 70, nor, and this is the key, nor has there been that VLAN assigned to either one of those trunks. See, if you notice here, when I look at the show VLAN output, there's all kinds of, good grief, where's it at? There we go. There's all kinds of things that don't have port, like VLAN 64, VLAN 66. There's no active ports, but it is added to the trunk here, whereas VLAN 70 is not. Thus, this interface will stay down until, and let me make sure I emphasize this, until I not only assign a port to that VLAN, because, matter of fact, I think there is a port assigned to that VLAN right here. So number one, until I assign a port to that VLAN. Number two, until something is actively connected to that port, because that port is in a down state. Now let me show you a quick way that you can trick it. Yeah, you can trick the ether switch. I can go into that interface and do a no keep alive, which says, hey, don't even check to see if there's anything plugged into that port. I'm waiting. Is it going to go up? Oh, come on, it's not going to do it, is it? Some switches still are like, hey, I'm not doing it. I'll say some models of switches, if you type in no keep alive, it will actually say, oh, okay, the interface is online now, but not this switch. But food for thought if you ever want to test it and pretend like there's something there. So, okay, where was I? Oh yeah, I was doing a lab. So the interface description, bonus material. The fact that VLAN 70 doesn't come online, I'll say bonus material, but boy, if you're studying for a certification exam, that would still be a good thing to know. So we've got that. We've got the point-to-point subnet configured, and once again emphasizing, let me bring back my config, emphasizing the difference between a VLAN interface, that's these guys. It's routing for the whole VLAN, VLAN 64, VLAN 66, and what's considered a routed interface, which we did in the last nugget, interface FastEthernet 1/15, turned off the fact that it's a switch port, it says it's now a routing port, and gave it an IP address. So now I've got that point-to-point subnet going between switch 1 and router 1. So let's get back to the lab. I think we can finish it if we focus here. So which it's hard for me to do that. So let's bring this back up and squeeze in and look at our last few things. It says configure switch 1 as the root of spanning tree of the spanning tree network for all VLANs. Enable all interfaces not being used for a switch uplink as port fast. So that should be fairly simple. And then the last piece is to configure the server, the PCs with IP address, and then we just got testing. So I think we can do this. Let's focus here. So we've got switch 1. We've got this guy being the root of spanning tree. And I talked about this previously. Spanning tree is going to say if this guy is set as the root bridge, that's going to get everybody else to say, okay, you are the core of spanning tree, and we will all point to you as the center. Now in this topology, I'll tell you, just because of the physical look of this, if you look at this physically, there's no other way for them to go. So for instance, if this guy were the root of spanning tree with this topology, it wouldn't matter because everybody would say, okay, you're the center of the network, but they would realize, well, to get down in there, there's only one way to get there. Where it would really come into play, and this isn't too far of a possibility, as if this switch ended up getting connected to this switch. Maybe for redundancy. Maybe you added another root bridge up here, something like this, like I was drawing before. Like you've got redundant connections. At that point, it does matter. For example, if this guy was the root bridge and these guys all converged, they would say, okay, I'm going to point to you, I'm going to forward to you, we're going to block this ether channel link. So everybody ends up going through this little layer 2 switch, which doesn't have near the capabilities of this guy, the backplane, the speed, all of that. It doesn't have near the capabilities, but just because we configured that or left it at default and maybe that guy got elected as the root bridge, now we've got an unoptimized, inefficient network. So it's good to set it either way. Now, I know we talked earlier about rapid spanning tree earlier in the series, and you might say, well, how come you didn't do rapid spanning tree? Well, the ether switch modules don't support it, which is common for a lot of older switches. They just don't support it. But I'll show you the command. It's just one command. So first off, let's set this guy as the root of spanning tree. So I'm going to do spanning tree. Hit question mark, and we will say VLAN. You might say, well, what's the VLAN for? I'm going to say for, let's just do 1 through 100. I'm going to say for all VLANs. And this is because Cisco actually runs a feature called per VLAN spanning tree. Okay, maybe we won't finish in this nugget. So I'm just thinking, okay, that's a big concept. Here's what that means. Let's say I had two switches like this. This is my distribution layer, and down here is my access layer. This is access distribution. So these are my layer 3 switches. The ones below are just my little layer 2 switches. What I can do is say this one is the root of spanning tree for VLANs maybe 1, 3, 5, and 7. You know, the odd number VLANs. The switch below is going to be the root of spanning tree for VLANs 2, 4, 6, 8. Or, you know, again, just an example in this case. What that would end up accomplishing is this guy would use this direction for these 4 VLANs as his primary path and block this direction. For the even number VLANs, let me grab a different color. For the even number VLANs, he would go this direction and block this link. So what you've done, and there'd be a link between these guys like that, what you've done by configuring it this way is set up kind of a rudimentary load balancing. It's not perfect, it's not going to be exact, but you've kind of split the VLANs to where even number VLANs go this way, odd number VLANs go this way, and then we could do the opposite on this one to maybe he's the backup route. For VLANs 2, 4, 6, 8, you know, to where his priority is set just a little higher than this guy for that. So if this guy ever fails, it kind of fails over. So again, he's now using this link for VLANs 1, 3, 5, and 7, and using this link for VLANs 2, 4, 6, 8. That's the power of per VLAN spanning tree. But in our case, we don't have redundant layer 3 switches. Switch 1 doesn't have a buddy. So in this case, we're just going to say, hey, for all of the VLANs, we'll say 1 through 100. Yes, I could do through 1005, and that'd be fine. But I'm just going to do 1 through 100. Am I missing something here? 1 through 100. No? Okay, this is different. Normally, a normal switch would allow you to type those in a range like that. It looks like this little ether switch module is going to make us go one by one, which is okay. Just kind of mean. Do show IP interface brief. So let's go down this list. Okay, we've got the 4 VLANs or the group of VLANs right there. So let's do spanning tree. Let's do VLAN. And I'll do 64. Let's do 64 first, and then we'll copy and paste away. And we'll just do root primary. Now doing this, and I'll hit the enter key right there. And by doing this, it runs a little script that automatically sets this guy as the root of that VLAN. It looks around and says, okay, what's the current priorities out there? I'm going to set him lower. Now, you don't have to do it that way. And actually, in the normal real world, I usually, instead of saying root primary, what I'll usually type in is VLAN 64 priority, and actually type in the priority. And you can type in, you know, it's going to, let me just show it. Good grief. I typed priority 3 because I thought it was going to give you an error message. Um, Wait a sec. Hang on. Spanning tree. This is those of you that have configured spanning tree on a normal switch know this is slightly different. Normally, if you type in a value of 3, it's going to come back and say, "Whoa, buddy, that's an invalid value. You have to use increments of 4096." I'm just curious. Let me do a show spanning tree. Let me just do a show spanning tree. Okay, VLAN. Okay, let me do show spanning tree. Let's do summary. So it is the root bridge. So it is already the root bridge for the VLANs, but show spanning tree. Where are we at? Brief. Let's do VLAN 64. Spanning tree instance for bridge group 64 does not exist. Bridge group 64. Show spanning tree. Does this not support per VLAN spanning tree? Hold on. Okay, I'm back. I just wanted to go verify. I just had to Google real quick and see what kind of spanning tree this guy supports. And so I was looking on here, and it does support. It mentions 802.1d spanning tree protocols are standard. So 802.1d, by the way, is the original spanning tree, the 1980 80 whatever version, the original one that came out. It's not rapid spanning tree, which is fine, but I wanted to find out if it was the per VLAN spanning tree. So I dug a little deeper, and it says that the spanning tree on the Ether switch network module, which is what we're using to emulate our switches, does indeed run a spanning tree on each VLAN, which is considered per VLAN spanning tree. So it just must be a little bit different than the actual switches, which is fine. I mean, the syntax is the same. It's just it runs different. And usually, if you set a priority of 3, it'll throw something at you on a real switch. It'll say, no, you got to use increments of 4096. So that, like I was saying, back to what my point. Usually, I'll go in and say VLAN 64 priority, 4096 or something that I manually set that is really low. But for now, I'm going to do spanning tree for VLAN 64 root primary and hit the enter. So that's now set, and I'll just hit the up arrow and do that same thing for all of the VLANs. Actually, tell you what, even better, I'll just copy and paste it all in here. And okay, paste that in, and just paste the rest of them in. So this guy is now set as the root. Now, you saw when I did the verification command before, it said, hey, I am the root bridge for all of those. But if you're in an exam environment or real worlds, you never want to trust that, because it probably just happened to be that this guy had the lowest MAC address of all the switches out there, so it became the root bridge. But nothing's to say that someone else isn't going to plug in another switch with a lower priority or lower MAC address in the future and kind of preempt and take over that root bridge function. So I've manually set all of the different VLANs to or spanning tree for the VLANs to that priority. And now the last piece of this is to enable all the interfaces not being used as a switch uplink for port fast. So essentially, again, port fast allows the port to go active immediately. I don't have to wait that 30-second timer for it to go active. So it's any port except for these. So trunk ports are the uplinks; those are exempted from port fast. So the command, if I want to configure port fast, is to go into the interface. So let's just do show IP interface brief, and then I'll go back to the diagram and make a list of them. So these guys are all the uplinks. Well, that's pretty much all of them. So all the rest aren't connected yet. So I've got 5 through 15. Now I don't know if 15 will take the command. Probably. So let's do interface range fast Ethernet 1/5 through 15, and we'll do spanning tree port fast. Hit enter, and you get this nice big ol' warning message for each one of them. Now again, on updated switches, and I'll stop saying this, but on updated switches it usually just gives you one because they've got the code a little more tuned to be a switch. But in this case it's just saying, warning, don't do this on uplinks. This is only meant to be on concentrate. Oh, look at that typo. Got a space. Cisco has a typo in their iOS. Unbelievable. Same thing here. So anyway, we've got switch 1 configured now for port fast on all those ports. So let's get that paste it in there, and then I'll do the same thing for the other switches. So there, I've got it in Notepad. Now looking at the diagram here, or not the diagram, but the port list, we've got Fast Ethernet 1/2 through 14. Those are going to be our access ports. Now the wireless access point is actually technically a trunk. That's how it's configured. So that would be considered an uplink. So what I'm going to do is just adjust my ports to be 2 through 14 on switch 2 and switch 3 instead of including that wireless access point, and of course exempting the 2 uplink ports, the 2 trunk ports that go to the switch 1. So let's hit enter a couple of times. Actually, to come back to GNS3, pop open a console connection here, and paste that in. So we've got that one going, and then shoot back here, console, enter, and paste that one in. So now we've got all of those configured for PortFast, and I would say that objective is now complete. So hang on, I'm looking at my time, and this is where I always get. I'm like, we can squeeze it in, but then we squeeze it in, and it takes too long. But I think we can, right? Okay, so let's do it. I'm doing it. Jumping. We're going to go to the server and PCs, get them configured, and then do testing. Let's make sure all of this is working as advertised. And you know what? I'm just thinking of time. I sure hope it works. If not, you'll hear a summary briefly after this, because I'll go back and splice it into another nugget. Because there will be some troubleshooting in there. So let's jump back here and bring up our connections to servers and PCs. Now in GNS3, the servers, the PCs, I'm actually using a router to emulate those. Meaning this is just a router, but you notice in my instructions, what I say is go configure the Fast Ethernet 0/0 interface with this IP address to make it like an NPC, give it a default gateway, and then turn off routing. So that way it's acting like a PC. It's not acting like a router. But I do want you to keep in mind that GNS3, you can go out of this world with it. They have now, in this version, they have VirtualBox Guest. VirtualBox is like an open source VMware or Parallels or whatever virtualization solution you use on your PC, to where you can actually install, get this, you can install Windows XP or something like that into this GNS3 environment, to where you actually click on this and open a Windows XP console that's acting like a real PC, or Windows 7 or whatever you want to use. QEMU is kind of a Linuxy way of emulating an nhost as well, but that's pretty exciting if you have the time to do that. I'm using routers simply because, good grief, that would take a lot of time, and then I'd be giving you GNS3 lab files that, I'm like, oh yeah, by the way, you just have to install Windows XP, and good grief, who wants to do that? So let's for now just go into the server. I'm going to open him up. And he has got no config. So again, in addition to what the lab is saying, just for our own sake, and actually while it's loading, why don't I get these connections open as well? Console, enter, no, enter. PC2 console, enter, no, enter. Okay, just get those guys loading up get all their stuff thrown out there. All right, so I'm going to go in, as I was saying, and just give it a hostname server. Now, lab said Fast Ethernet 00, should have that IP address. So let's go in there and do it. Interface Fast Ethernet 00, IP address, it is 10.1.68.50. No shut. Get that guy brought up. Now I'm going to turn off routing. This is maybe a new command for you. No IP routing. And hit enter, which makes this thing just as useful as an NPC, which is exactly what I want it to be. And then I'm going to type in IP default gateway. To make this act, just like an NPC that has a default gateway. It's on the server VLAN. Again, I gave it an IP address from the server VLAN. And actually, you know what? I'm all ready to test. And this guy should already be assigned. Hang on, let's bring up the ports. Oops. Oh no, what have I done? No. Okay. Wait a sec. What port is this guy connected to? Server. It's connected to switch 1. Okay, that's funny. It's just not showing up there. So switch 1, Fast Ethernet 1/4 4 is where we are connected. I wonder why it's not showing up there. That's odd. So that's our physical connection. So I just want to make sure. Let's go into switch 1. Just verify. Show VLAN switch. And yes, it is in VLAN 68. So if everything is done correctly, and look at this, we even have duplex mismatches. That's fantastic. Let's fix that while we're here. I'm going to go into fast Ethernet 1/4, speed 100, duplex auto. Oh, what am I doing? Full, and type that in. I'm going to go over to the server, who's also complaining at me. Interface fast Ethernet 00, speed 100, duplex full. Actually, I'm going to make a note, add that to the lab, because that will be something that comes back to haunt us. Jeremy, add speed and duplex for end devices. Okay, so again, by time you see the lab, you're going to go, what are you doing? Of course, it's in the lab. It's because I added it. So I'm going to go in there. We've now reset that interface, and now I should be able to type, and I should be able to ping my default gateway, the layer 3 switch. Let's try it. Ping 10.1.68.1. And don't you hate that pause? Okay, yes, we are successful, which means the server's in the right VLAN. It means our layer 3 switch is layer 3 switching. It's receiving the request on that routed interface that we created. We should even be able to ping off our VLAN. There's no security restrictions yet. The only other active VLAN is that management interface. Look at that. That tests to make sure that our routing is working. It tests to make sure that our default gateway is working, because otherwise this thing can only reach things on that 10.1.68. Let's do a trace route. Well, hang on. Let me do this. No IP domain lookup, or else trace route takes forever. Trace route 1.71.1. So, well, not too exciting, but it just shows that we're going through this, and then we got to there, which happened to be on the same device. That's our management interface of our switch. Good. Okay, so good. Let me get all this in the Notepad file. And you guys know when you see this, when you see, for instance, let's see, no IP domain lookup. I'm putting it in the answer file, but it wasn't part of the lab. It just will save you a lot of time when you're doing trace routes, because otherwise it tries to resolve every hop via DNS, which doesn't exist. So I'll hit. Okay, so we've got the server done. Now it actually should be as easy as doing this. Let's do. Actually, let's even copy this guy up here. Just paste it in there. We've got PC1. And then PC2, hostname PC1, hostname PC2, and then I'm just going to update the IP addresses there to be in the right VLAN. So let's grab that. Actually, I can pause it, and I'll just paste it all in. All right, there we go. I've got all of the IP addresses typed in there and ready to go. So I'll just paste them in, and then we can jump into the testing. So copy. Let's go in. Enable. Paste that in. Good. Save. Oh, let me save the server too. Save. And then PC2. Enable. Jump back here. PC2. Paste. Good. So we now have the server and the PC configured with all of this, and by the time you're seeing it, you'll have a few more instructions there with the speed and duplex and all that. So let's do our testing now. And this will bring our layer 2 config to a close. PC1 should be able to ping PC2, and let's look at our diagram. Oh man, what a test. For PC1, I mean, it's like we take that for we take that as like, oh yeah, that should be no problem. But I mean, look at that. To make that happen, PC1 has to go through here. So we have to have this set to the right VLAN. We have to have the trunking correct with all the VLANs going across there. Trunking correct here, and this set to the right VLAN. Doing an end-to-end test of PC1 to PC2 that's a big deal. That tests a lot of what we did. So let's bring it up, hold our breath, and do it. Well, we don't hold our breath here. We know it'll work, right? Alright, so let's do ping 10.1.66.51, which is the other side of the diagram, diagram, and there we go. We've got, that's awesome. We've got now an end-to-end test showing, that just shows that the client VLAN truly does go through the entire topology, and that we have everything assigned to the right VLAN. Good. So test 1 is passed. We now have PC1 and PC2 should be able to perform a ping and a trace route to the server. Well, let's just do it. Let's do PC1 ping 10.1.68.50. Yes, is that the right IP address? 68.50. That's the server. Which will test routing. This will test routing through our layer 3 switch, and there we go. We now have a ping successful to the server there. Let's hit the up arrow and do a trace route. And look at that. Now it shows us going through the layer 3 switch, and then actually landing on the server. And by the way, don't let this worry you. It always drops the second trace route of the last thing. And it's funny. I actually did a big thing. I researched why that was. Cisco has a whole explanation of why that is, and I totally don't remember, but it doesn't matter. So I'm going to go in PC2 because it said both of them should be able to ping 10.1.68.50 the server. And PC2 successfully gets there. And just for fun, we'll add in the trace route. And it shows us going through the layer 3 switch, hitting the server right here, and then the server's coming back to us. Cool, this is cool. So we've got that. It shows spanning tree should reveal that switch 1 is the root bridge. And I think we did that before, but let's just do it again. Show spanning tree. We've got, okay, there's our port channels. Yada yada. Okay, there we go. So we've got VLAN 64 executing IEEE spanning tree protocol. That's 802.1d. Look at this. I can't believe it took that. Priority of 3. This can't be running per VLAN spanning tree because that's the whole reason you can't use a priority of 3. But look at this. So VLAN, okay, so port of VLAN 64 is forwarding. So we've got VLAN 66, and it shows all the ports of that VLAN. So they're showing priority 8192. Well, this is funny. I just did this to show that it wouldn't work, but it did. But I'll tell you, in the real world, you won't be able to set a priority of 3. But nonetheless, this bridge is the root of spanning tree. You can see right there. For VLAN 66, schizophrenic. We are the root of the spanning tree protocol. And we could go down through all of them and see that we are the root of spanning tree that we're able to verify in there. Good. So that verifies that switch 1 is the root bridge. And then finally, you should be able to telnet and SSH to each switch, PC, or server using the management interface IP. Crap. Wait a sec. We didn't. Okay, I'm going to have to revise this. To each switch, because if this really is a PC or server, we shouldn't be able to telnet or SSH to that. So I'm going to remove that. So we're going to just be able to telnet or SSH to each switch or server. So let's test that. I'm going to go. Let's go to our server. And hang on, I got to go back to the lab and verify the management IP addresses. There we are. So 1, 2, and 3, easy enough. So let's telnet to 10.1.71.1. Look at that. Oh, wait a sec. Admin, Cisco. And we're on. So switch 1, Control-Shift-6, X. Let's do... Well, I'm glad we tested that. Kind of. So hang on, let me look at switch 2. Show IP interface brief. Did we set up a management IP address on here? Management 71.2. Am I sure that didn't work? Why is it not working? 71.2. Oh, wait a sec. Hang on, 71.3. Let me just try that. I didn't. Man, I'm finding. I should work through these labs before I actually do them with you, right? Wait a sec. We set the management IP address. I never said we need to set the default gateway. Now, how am I going to fix that? How do I fix that? That's lab 1. I've got it. I never set a default gateway on switch 2 and 3. Duh, idiot. All right, so we've got. So here's the problem. Let me do a show run. We have this switch. 10.1.71.2, which has an IP address right somewhere at the bottom of this list. has an IP address on VLAN 71, but doesn't have a default gateway. So it's not able to get off its VLAN 71. So Jeremy's going to have to figure out how to squeeze that one in. And default gateway for the switches. I didn't even think of that. Why did that escape my mind? All right, so let's go in. IP default gateway. And again, switch 2, switch 3, where are they going to go to get off of their VLAN? Switch 1. That's the route interface. So this guy's going to say, okay, I'm on the management. I've got to go up the trunk, hit this guy. He's my router. He's my default gateway to get off the network of VLAN 71. So let me get back there. Default gateway 10.1.71.1. Good. And then let's copy that guy into switch 3. 10.1.71.1. Okay, now let's try it. Telling it to switch 2. You're killing me here. All right, so hang on. We got switch 1. Hang on. 10.1. Show IP interface brief. Include VLAN. 71.2. That's right. Right. Hang on. Ping 10.1.71.1. There's 1. 2. Not successful. 3. Not successful. We were there. It's the last test. All right, what am I missing here? Let's see. We've got, let's see, VLAN 71. Oh. Wait a sec. See, here's the problem. Because we've got, okay, switch 2 and switch 3. Let me get back to my whiteboard here. Switch 2 and switch 3 are actually routers. It's a circle. It's actually a router with a switch module inside of it. So here's the problem. I typed in IP default gateway, but it's not going to use that default gateway because it's like, I'm a router, buddy. I'm not a switch. I'm not a PC. I don't use default gateways because I'm a router. I know everything. I would use a default route. So there's two ways we can fix this. I would say probably the one that would closely match reality that would be to disable routing, and then it'll use its default gateway. Or we could go in, since these are real routers, and I could type in IP route, you know, you know what I'm talking about. Default route 172, or wait a sec, 10.1.71. And I totally messed up. I'm just typing fast, right? So no IP routing, the missing piece. Because these are not routers, they are switches, at least in our lab. No IP routing. Hit enter. And now they're disabled. Now, there we go. Now we're going through. 1.3, and there we go. Good. And that, again, I'm not going to reiterate all that because I just said it. So that's the final piece. Now now if you were me, what would you do? Like in this testing, you would add like sub-bullets. By the way, before you do this test, wait. So I'm gonna have to revise this lab to reflect that. So those of you that take on this lab on your own before you go through this walkthrough will have a good idea of how that works. So, whew. So that is intro theme music, configuring the switch infrastructure, working through all of the pieces of that. And I think I'm going to. I've got to split this into a part 4 and part 5. So I hope this has been informative for you, and I'd like to thank you for viewing.